So hi, my name is Richard Stepp with the Roadway Design Office in Tallahassee. It's a central office. I'm a standard plans engineer. Over the past year, I've worked predominantly on revising and redeveloping the standards that I have listed here in front of you. And so today I plan to just walk through some of these standards and give an overview, call out on some of the sheets, some of the changes we made that might be of interest to designers. And so we have made changes to the guardrail, as Derwood pointed out, concrete barrier, pure protection barrier, some inlets that work along with our barriers, and then standard aluminum lighting, so as it relates to the barriers. And you'll notice the theme here, it's the single slope barrier. And so basically we're going to just be showing you all the effects that the single slope barrier has on all these different types of indexes. So starting off with the guardrail, just some quick miscellaneous updates that might be of interest to the designers. We'll just quickly go through those. And so we did make some changes for single slope barriers. Basically, the barrier itself, as it connects to guardrail and the offset blocks have changed. We've got some miscellaneous updates for constructability and clarity. And today's presentation covers, designers' items of interest for designers, and that's true of all the future indexes we're going to talk about. We have made lots of little miscellaneous changes and improvements for the clarity of what contractors are doing in the field, but today we're just going to focus on the things for designers. And so for the complete red lines of all changes, if you're interested in that, you can see the Office of Design Industry Review website at this link. And okay, just going through a few things we've changed with the guardrail concerning the designers. We had received some input on this. So in the recently released standard, we went ahead and called out the maximum slope on shoulders for proper guardrail function. And so we had heard some feedback that, well, now maybe contractors might only look at the 1 to 10 max and then not realize that they need to be looking to the plans. And also designers might see this and think that, okay, they only need to meet 1 to 10 max. They don't need to look at the FDM. And so while it didn't really cause any conflicts, we just wanted users to realize that this was not the only criteria. So we went ahead and removed that as it's called out on the shoulder pavement. Now we did leave the 1 to 10 max in a few locations, just a generic cross section, and then behind the curb, because still we want to drive the point home that 1 to 10 max is the maximum slope for guardrail function. And then in order to leave that in there, we went ahead and add a little note that just explains the 1 to 10 max is for proper guardrail function only. And if you want, to see the project specific cross slope, you need to be looking at the plans, and then obviously the FDM governs the plans. And so now we're just showing some examples of single slope barrier as it shows up in the guardrail standard. This had been modified in multiple sheets, so we're just going to show you one of them. And so here you can see now we have this new little taper down at the very end of the concrete barrier, because now the new barrier is 38 inches high, but we still need to end it at 32 inches high to prevent kind of a snagging hazard of errant vehicles could hit the guardrail and slide along. We don't want them to snag on the concrete, so now it's got a little taper down. That shows up in the section views as well. And we have also revised some of the offset blocks. We had to finagle these a little bit to make it work properly, but we were still able to just keep it so the contractors have to make one cut, but the offset blocks got a lot thinner because the barrier sections are thicker up high. And then from the design point of view, we were able to make this so that the guardrail width at the connection point doesn't have to change at all. It's the same as it has been in the past, so nothing's changed as far as that's concerned. And then the last point we're going to mention for guardrail is we've added the ability to terminate the pipe rail on a steel post. And so in the past, I think the assumption was that, basically the purpose of the pipe rail is to be providing some degree of protection for pedestrians and bicyclists when a sidewalk or shared use path is within 4 feet of the back of a steel post, because there could be some sharp edges on the steel flanges. And so the idea is that, okay, well, in an urban area, typically you would end with a timber post approach terminal, and then you don't need the steel pipe rail. So you go ahead and terminate on a timber post. Now, it could be a case where simply the sidewalk comes near the guardrail post and then veers away, and then you don't need the pipe rail anymore. So now we've added this new option so you can terminate on a steel post and not have to worry about putting in a timber post among a run of steel posts, because we had gotten some questions about designers on that. So now you have both options. You can end it either way. Okay, so now we'll move on to speaking about the concrete barrier. This is the most extensive project I'll talk about. Moving through these indexes, it's the lengthiest, but I'll explain why. So basically all the barriers were upgraded to the single slope sections to accommodate larger vehicles for MASH compliance. And the standard plan sheets were completely redrawn, rewritten, reorganized just to improve the clarity of notes for details for designers and contractors to more easily understand what's going on in the indexes. We also introduced some new standard plans instructions, or SPIs, just to improve the clarity of the process for designers. It's kind of an educational material. It's a good starting point if you've never designed concrete barrier. We also have a new length of need design tool to assist designers with learning the AASHTO Roadside Design Guide barrier length process. It's very similar to the one used for guardrail. And so we'll take a look at those. And then, again, today's presentation just covers the select items of interest for designers. So looking at sheet 1 now, we've got a new table of contents over here on the left, so you can more quickly get the information you're looking for. If you notice, we've organized these. We now make it clear there's just 3 distinct barrier types. So we have the median barrier, shoulder barrier, curb and gutter barrier, and we'll define those as we move into those sheets as we step through this. We've rewritten the notes throughout with concise active voice with headings. So again, rather than just a solid sheet of text, when you're trying to find specific information, you can now just look through and look for the note heading that interests you that you need to know about. So we've got a new welded wire reinforcing option for contractors. So that's just a note letting the contractor know that they can substitute a welded wire reinforcing for all of the steel rebar mild steel reinforcing that's shown. And then an item of interest for designers is the minimum barrier length is 40 feet. That's just required for a dead load to resist overturning upon an impact. And then we've also have some miscellaneous items for contractors here. So okay, moving on to sheet 2 now. This is the first sheet and like the median barrier grouping. So the sheets that immediately follow this are all median barriers and variations of median barriers. And so I like to start off each section with just a simple plan, elevation, and section to show the most basic type of median barrier, just so contractors can get their bearings. And then we show connection to guardrail, connection to traffic railing wherever it's applicable, just as examples for the contractor. And then one thing that's new and interesting is that for this particular connection median barrier, you're going to be connecting to double face guardrail, and that requires some length where the guardrail panels are at the same elevation. And for that reason, we've come up with a segment that needs to be 16 feet long, where you have symmetrical median barrier in order to accommodate that connection to guardrail. So for the last 16 feet, you have to use your basic type of median barrier, which is 38-inch height shown here. And then after that, you can transition into the sign support type of barrier or grade separated barrier, or basically all the options we're going to show you on the upcoming sheets. And speaking of the options on the upcoming sheets, we now have 4 pay items for median barrier, which the first one is just 38-inch height symmetrical, which is shown here. That's the basic. And then the next type is short grade separated, which is on upcoming slides. And then the tall grade separated, which gets even more complex, add the footing to it. And then the last one is just variable section for sign and pier shielding. And we want to more accurately capture the costs on these per linear foot. So previously, we just had one pay item for all these different types of barriers, and we weren't really getting accurate costs per project. So this will help with that. On the next sheet, we're showing a new reinforcing we've added to the median barrier. Essentially, this provides some nice continuity for intact of larger vehicles for MASH. Provides support. This is the minimum possible reinforcing needed in order to slip form properly. And so it prevents the concrete from slumping. These are taller, narrower barriers. And so now we have reinforcing in these as well. And we also show the details on this sheet for narrowing down the section for connection to guardrail. And you can see we have our 3-inch cutback to avoid that wheel snagging. And then the height also reduces to get down to guardrail height so that vehicles won't get snagged over the top. So looking at sheet 4, this is for our sloped end treatment. Now this is basically used, obviously, the medians for median barrier on the trailing ends and then outside the clear zone. So anytime you have approaching traffic that's within the clear zone, you're going to want to shield the blunt end with either a guardrail approach terminal or the crash cushion. But then this is just for the trailing end and then outside the clear zone. And so the usage is explained clearly in the new SPI. We have a nice table to explain end treatments for approach and trailing ends of all of our barrier types. But this is what that's used for. Okay, now this is, from a design standpoint, our grade separated barriers is very similar to the previous standards. And that's a note I want to make too. When I say all new, I mean it's completely redrawn. All the notes are rewritten for clarity. Obviously move the single slope barrier. But most of the concepts are carried forward from the previous standards. That's why I'm not going into detail on every concept. So it is similar to the previous standard in terms of how it works with grade separation. Minor changes in the heights that apply. We also, it's important to note, we have a little bit larger spread footings for MASH, which are seen in this table. And so, if you're used to the footings being a certain width, you just know that they've gotten a little larger. So you can account for that when you're planning which footing you want to choose and where your utilities happen to be. And then moving into sheet 6, which is for supporting signs. This is the option with the minimum width barrier section. And we have an upcoming option that's, can accommodate a larger if you have more lateral clearance. But anyway, so we've clarified where the project-specific reinforcing goes up here as needed to basically support the overhead sign support and then connect that continuously to the foundation. And this is all a project-specific design that'll need to typically be made by a structural engineer and placed in the plans. And the notes here make it a lot more clear of what needs to occur in terms of what needs to go into the plans in terms of project-specific reinforcing. The one other thing I wanted to mention is that the pedestal width and then the overall length of transitioning to this width is governed, obviously, by the project-specific width of the sign support. Now, the maximum we've stated that this pedestal can be is 2 feet wide. I'm sorry, actually, that's the minimum, is 2 feet wide. And that corresponds to the width of the barrier. So if the pedestal width is 2 feet wide, then there's no taper, which we say is permitted in the note. And then this just becomes the linear section that we had a whole sheet dedicated to this in the previous standard. But it's really the identical design. It's just that the pedestal width is only 2 feet wide to match the barrier. And so there's no taper and everything else is the same. So there was no reason to have a whole new index sheet just to explain that. So we placed that in the note, and that's acceptable to have the pedestal width be 2 feet wide. This is basically the same thing, just asymmetrical. So now you got a shoulder reduction on one side. And then, as I was mentioning before, the previous sheet I showed you was for the least amount of lateral space, the least amount of width. If you do happen to have some lateral space available on your project to fit this, some designers may prefer to use this option where you have an overhead sign support that you're shielding, but it's just independent of the barrier. You don't put the reinforcing through the barrier, and the barrier just basically goes around it. And so some designers might prefer that. And then also, this index sheet can apply if you happen to have an existing sign support and you just need to have some barriers that will go around it. And now we're getting into shielding of the pier. And I just want to point out that this, as opposed to pier protection barrier, which is the next index we'll talk about, this is shielding the pier, but it's only really for the crashworthiness benefit of the vehicle. So it's basically, we're talking about the vehicle safety. And then the assumption is that the pier is designed to withstand the impact of larger trucks. So if that's the case, the pier, you're not really trying to protect the pier itself, then you can go ahead and use this index sheet. And now when the pier is not designed to withstand the impacts, you want to use pier protection barrier, which I'll show you in the next index, 521002. And now I realize I just wanted to throw this concept out there. You know, people may want to give it some more thought, especially if you're designing a new project. We have guidance on this that begins in the standard plans instructions, and then the FDOT design manual as well explains that process a lot further, deciding whether or not you need pier protection barrier. And so on the next sheet, we just have some cross sections on the geometry you'll need to fit in your plans that go along with the previous sheet. We have all the cross sections cut, and then they show up here on the next sheet. Okay, so now this is something that truly is all new because we're transitioning between the existing old F shape and the new single slope barrier. Or you can transition to a single slope traffic railing. So really this handles any combination of going back and forth between single slope and F shape. And we just generically say F shape section over here on the right for that reason. So for example, you can have an existing bridge that's kind of an older bridge, has an F-shaped railing on it. For whatever reason, you're putting in a new roadway project and you want to use the shiny new single slope. And so over here on the left, you're using option A, which is the 38-inch high medium barrier. And basically you're just going along, and then you have your 10-foot transition. You have a continuous concrete between the new the new single slope and then the transition segment that goes to F shape, and then you would dial into the existing if that were a traffic railing. Now, also on the right side, you can say that, well, out there in the field, you have miles and miles of F-shaped barrier, but you want to install a bridge, and you know design life on a bridge is pretty long, so you want to put the nice new single slope in there. So in that case, you use option B over here on the left side for the traffic railing on a bridge. And then over here on the right would be the existing barrier that's out there, just the roadside item. And so you have your 10-foot transition, and then before you connect to the new bridge, we want there to be a minimum 2.5 feet. This actually gives a little leeway for the contractor that's outside of this 10-foot, because this will probably be a pre-made mold. And so then they have 2'6" minimum to make that connection to the bridge, because you're basically going to be between two solid objects, and the odds of getting the length exactly right are pretty low. So it just allows some flexibility there. And then also 12'6" is the min, just for dead load considerations. So moving on to sheet 12, we're now kicking off the shoulder barrier kind of grouping of the index sheets. And again, we start each grouping with just the basic elevation plan, section view, the contractors getting their bearings, and then how to connect to guardrail. In this case, it's more simple, just for a single face shoulder barrier, and then how to connect to traffic railings and the like. Now, shoulder barrier is typically used on outside shoulders, basically where median barrier and curb and glitter barrier is not used. You use this on the outside shoulders. Generally, you know, if you had lateral clearance available for deflection of guardrail, that might be your first option. But if you were shielding a lot of things on the roadside that were very close to the barrier and you needed something very rigid, then you could elect to use the shoulder barrier. So now this gives you a preview of what the upcoming sheets are. So you have 3 pay items for shoulder barrier. It's pretty similar to the past. So we have the 38-inch and 44-inch height. The BOE, that's explained pretty clearly that those are the same thing. And that's just the basic shoulder barrier as it looks right here, this section. We allow it to move up and down to reduce the ZOE requirement without changing pay items. So that's why there's 2 heights permitted. We have a retaining section we'll see on upcoming slides. We have a trench footing section on upcoming slides. And so go ahead and move into those. Quickly before that, we'll just show you, we have some reinforcing details. Again, we have the reinforcing showing the transition for guardrail where the section actually narrows. It also gets shorter to prevent snagging. And In the previous standard, I don't think we really had the details to show the connection for guardrail in this case, so now we've provided those. And then here are those alternative sections. You can select these as a designer as required. The retaining section here, one thing to note is that the heel has been extended by a foot to help support this soil. And so that's new in the new standard, so take note of that. And then now we have a new trench footing option, which could be more convenient for contractors. It's a little more simple than the spread footing design. You know, if you don't have any issues with depth of utilities or anything like that, you can consider adding that in. And then a couple more sections to accommodate basically reducing the setback requirement or zone of intrusion. We're talking about shielding piers, and those work on the next sheet. And then, again, as I mentioned before, this 44-inch height section, well, just raising it up a little bit, can still use the same pay item as, you know, the so-called standard 38-inch height. And so that's clearly explained in the BOE. Okay, so again, I'm going to go just quickly at a little spiel about the pier protection. And this is only really for the benefit of the vehicles. We're assuming that that pier is designed to withstand impacts per the, you know, the SPI, FDM, and then eventually LRFD requirement. That's all explained clearly in these documents. And so that is the limitation on this, is it's assuming that the pier is designed to withstand the impact itself, and we're just providing shielding for the benefit of the vehicle. This particular sheet is designed for low speed as opposed to the next sheet. And so it's less than or equal to 45 miles per hour. And what happens is the setback requirement for a zone of intrusion, if a vehicle were to hit this, basically drops to 0 when the design speed's low. And so the height of the barrier is not a concern in terms of zone of intrusion. And so we went ahead and had an option where we keep the barrier height the standard 38 inches. Just from a construction standpoint, it's just simpler and less expensive, so it's more efficient to have this option. And then we also have two options. So the first thing you would go for is to keep the full section width when shielding this pier, just out of ease of constructability for contractors. If you absolutely had to, because you're very pressed on space, you can go with the section that has a 3-inch reduction, where the barrier essentially wraps around the pier. And so on the following sheet, it's the same basic concept, except for this one is used for all design speeds. And because of that, in order to reduce the setback requirement, we've raised up the barrier, basically to reduce that setback requirement of the FDM, reduce the zone of intrusion. And so for all design speeds, you got to raise the barrier up a little bit higher. And then again, we got our transition to F shapes, back and forth between single slope shape and F shape. It's the same concept from sheet 11, only for shoulder barriers. And so we don't need to give this too much explanation. Same concept we got to cover for shoulder barriers. And then the final barrier type is the curb and gutter. It's basically the third category in here. This was simplified from the previous design a little bit. It's typically used in urban areas for designs to be less than or equal to 45 miles per hour. That's basically the same restriction on the type F barrier, or the type F curb, I should say. And it aligns with the type F curb pretty nicely for water conveyance. That 1'4" is basically the exact width of the front of the type F curb. And so those align, and it's kind of like your urban option. It has its own curb and gutter pay item, and then new guardrail connection details. And then, so the one point to emphasize moving forward is that the guardrail approach terminal is basically now becoming our primary first choice option for protecting the blunt end of this barrier in an urban area. So you're going to want to try to use an approach terminal. And then that's opposed to, in the previous standard, the only option we had was a sloped end treatment. And really, we just only want to use that where we have no better options, and that will be become like the last resort. And we have some restrictions on that. I'll show you in upcoming slides. The reinforcing details, you know, for the general run of guardrail here, or, sorry, for the general run of a barrier are shown here, and then also the reduction in section width as it connects to guardrail. So we have that all handled. And then, as I talked about, this is carried forward from the previous standard. the sloped end treatment only, like I said, this is considered the secondary option. It does have some restrictions on use. So this can only be used with design speed of less than or equal to 35 miles per hour. Requires DDE approval, and these requirements are seen in FDM 215, and the SPI will also refer you to the proper location in the FDM. And that's what I said. So the requirements are explained in the standard plans instructions. Got some reinforcing details for contractors, and then that wraps up looking at the index sheets themselves. Now, one thing I did want to show you really quickly is the new standard plans instructions. And I do consider this kind of like an educational document. If you're a new designer, this is the first place you would look to understand how things work. So the idea is that, go ahead and open this, see if it opens. You know, this we would hope would be written more clearly than I can explain in this brief instruction that I'm giving today. But I just wanted to give you the overview so you have a feel for it. So the next time you open it up, you'll already have your bearings. So we give a brief explanation on the concrete barrier types, median, shoulder, curb and gutter, the design speeds that apply, what they're typically used for. We then go into shielding hazards and what our basic method is for determining the length of need. That will refer you to the FDOT design tool, which I'll show you next. We've got the different end treatments, explains on approach and trailing ends, what you would do for all the barrier types. And then how to, connect to different types of barriers, and then just general plan content requirements. So I just wanted to give you a brief overview of what's in there because that's all new. Okay, and moving along, as I mentioned, the design tool for length of need. It's an Excel spreadsheet. I'll just quickly open that so you get a feel for it. The one thing I want to point out is this is very similar to the length of need design program for guardrail. We have a training on that. It's a 17 training on our website. If you look at module 4, that explains the length of need calculations using the Excel sheet. So this is very similar. I just want to give you a quick look. So, vehicle down here going from right to left, you're shielding this hazard. It just explains how to place the barrier and how long it's needed. The design input should be defined pretty clearly. And mostly this can be seen as kind of a learning tool just to understand AASHTO roadside design guide, because that's the basic process that we're using. We then consider two-lane, two-way. If you're in the clear zone from this lane of traffic over here on the left, going from left to right, you go ahead and design for the opposite side. So just wanted to show you that real fast. Okay, now we're moving into pier protection barrier. This is significantly shorter than the concrete barrier, so we should get through it a little more quickly. And I call this an extensive redevelopment because we did redraw and rewrite all the notes, but some things like the crash wall and the footings were in pretty good shape in the previous standard, so we were able to just copy them forward almost identically. So here we've revised sheet 1 for the general notes. We got a new table of contents so you can quickly find what you're looking for. Revised some notes for clarity, added note headings so you can quickly find your information. And the example layouts, these are helpful for designers and contractors alike, just to understand what to do in various situations when you're placing this type of barrier in the footings around the piers that you're trying to protect. And we also now show in this example the optional crash wall, and then a connection to guardrail or concrete barrier connection. And then one interesting thing I want to point out is that if you're connecting to concrete barrier, here we're showing guardrail, but you can also connect to concrete barrier for the previous standard, which is the smaller barrier than pier protection barrier. Then the crash wall would start at the end of the pier protection barrier, 0 offset. If you're connecting to guardrail, you're going to need to set that crash wall 3 feet back, as is shown, in order for the through bolts to work properly. So you need to provide space for that. So that's a difference in geometry you need to be aware of. We've got a new plan and elevation sheet showing all the different combinations of height and what you're connecting to. And so essentially, you need a 56-inch height barrier. If the pier you're shielding is within 10 feet of the back of the barrier, you need a 44-inch height barrier, a little bit shorter up here, if your pier is more than 10 feet behind the barrier. And that's, I think, an LRFD standard. The guidance is provided in the SPI so that you would know that. And then down here, we show the difference in connecting to concrete versus guardrail. You can see the 3-foot setback for the crash wall. And then here we've got some reinforcing details. This is for connecting to the 38-inch height barrier at the end, so we don't need to come down quite as far as for guardrail. And so all the reinforcing details are handled. We've then got our connection. Now we're coming all the way down to 32-inch height. This very last little section here to connect to guardrail to prevent all the snagging hazards with the concrete if a vehicle were to hit the guardrail. And here we have differing footing options. Basically, it's the same type of dimensions for the previous standard. The requirements for the impact loads didn't really change. And so these were nice looking details. We were able to carry them forward. And then finally, the crash wall. This again has the same basic geometry as the previous standard. And then the one thing I'll point out is, just we added a little point here, station and offset for crash wall. If the roadway designer put that in their plan, the point, it then defines all the rest of the geometry per the standard. So that, that point's important. That's also would be the length of need point as well in terms of the station. And we've got some reinforcing details for contractors, and that wraps up the index sheet portion. So again, we've heavily revised what used to be the instruction for design standard is now the standard plans instructions. We just gave it the kind of the organizational structure of the guardrail and the concrete barrier just to make it easy to find your way around and find the information that you're looking for. And anyway, but I won't open that right now just in the interest of time. But again, we look at kind of the SPIs as kind of like the educational material. It should be explained pretty clearly and just to help you learn about the design of pier protection barrier. And then one thing I will open, this is all new again, is the length of need design tool for designing pier protection barrier. So I'm going to go ahead and show you a couple plan layouts on what you'd be designing. So again, this would be for the simple pier protection barrier, and you can see where your length of need point is to shield a pier for vehicles that are moving left to right. We then have the opposite direction for 2-lane, 2-way. If this pier happens to be within 30 feet, then you need to design for the opposite direction. And then I wanted to show you the crash wall. The purpose of the crash wall is to reduce that overall length of the system. It reduces considerably, as you can see, from this length to this length, because you're gaining a lot of lateral offset, which reduces your length of need. And then the one other thing I want to mention is that if you are using a crash wall, the assumption is that you're going to be placing guardrail in front of it, and you typically would have a connection to guardrail. So for the benefit of general vehicles, you need to shield that crash wall from, for the, like I said, for the benefit of the vehicles. And so the guardrail would need to extend at least to this point. And so that's another thing I want to point out. The crash wall is considered a hazard to the vehicles, though it protects the pier itself. Okay, so moving on to our inlet types as they work with barriers. These should all go much quicker. They're just 1 or 2 sheets per index. So in this case, we have our typical revisions for single slope, as you can see. So we've, kind of cleaned up a lot of these details just to make them a little more clear and easy to follow. Switch everything to single slope, switch the inlet detail. We've removed the throat indentation. You can see on the isometric, it used to be up here, typically upstream when you have water flowing towards it. Speaking with Carl Spirio, the state drainage engineer, we've recognized that the benefit from that wasn't quite worth the time it took to construct these things. We found that a lot of cases, contractors were just kind of chiseling out like a throat indentation here, and it wasn't really performing as we had intended. We noticed a lot of cases it was collecting debris and trash and things. And so for the sake of simplicity, we just went ahead and removed those throats. And then what that did was remove the quantity of basically the combinations of types of inlets from 5 to 2, because it used to be you had either one side of the wall or both sides of the wall. And then with all the combinations of all the throats, there was 5 types. Now there's only 2. It's either type 1 is inlet on one side of the barrier. Type 2 is inlet on both sides of the barrier. So that's gotten a lot more simple. And the one other thing I wanted to point out, because I've seen several designers had sent me drawings where they were trying to make grade separated work with the single-sided inlet, where you can see that the actual wall of the inlet supports the barrier. So this is not designed for grade separation. Typically, when you need grade separation, you have to be using the double-sided, and that's all that really accommodates that. That was stated in the previous standard and the centerline note, but we just went ahead and made that a lot more clear. The single box is for symmetrical only. Okay, moving on to shoulder barrier inlet. So this one's pretty quick. We just switched things to single slope. We clarified the usage. And I guess the major change is just changing the name of this index sheet. So it used to be called barrier wall inlet, which is very similar to the 3 other types of inlets that work with barriers. And so the usage really wasn't clearly distinguished with the index title, but now we've made an effort to do that. So in index 521001, as we've seen, there's the median barrier, shoulder barrier, curb and gutter barrier. And so this one works with the shoulder barrier. So we just wanted to go ahead and make that clear, and then we call out exactly what index it works with. And that's basically the only change there. And then moving on finally to the 3rd type of barrier in 521001 is the curb and gutter barrier inlet. And so we've clarified these details significantly. These are completely redrawn. They look a little bit clearer now, easier to follow. You can see that, you know, the heel here, this all corresponds exactly to the curb and gutter barrier in 521001. They work together and align the same. And again, we removed that upstream throat. It was kind of the indentation underneath the barrier. That's gone now just for simplicity. And then the final significant change here was that the previous standard had an 18-inch drainage slot. It was kind of at the most narrow and vital point of the barrier right here over the inlet. And that was basically going right through where reinforcing should be and things like that. And so to make a more robust structure that's, you know, has improved constructability, less interference with the rebar, we've switched that over to 3.5-inch PVC pipes. The designer can call those out at sag points and curves, otherwise as a note for contractors to place them in at the low points. And basically that's for draining the sidewalk into the inlet. And so we now are using the PVC pipes, and that also was approved by the state drainage engineer. And then last but not least, single slope barriers, how that affects the aluminum lighting standards. So you can see we updated a single slope throughout. Now, because for medium barriers, we have continuous reinforcing, we've also had to change this segment that supports the lighting foundation to also have continuous steel so that it corresponds to the medium barrier, which also has continuous steel. And then the one thing I like to keep bringing up, because I have seen this in some projects in the past, the difference between the traffic railing, which goes on a bridge. We've recently made this distinction more clear, but the traffic railing typically is the item that goes on a bridge. The concrete barrier is what goes on a roadside that's supported by soil. So there's a difference there. Difference shows up here, where this is concrete barrier supported by soil. The conduit runs underground next to it. And so we have seen plans that had conduit running in the barrier, and that caused all kinds of issues, and it's not a standard, so I just want to point that out. Conduit goes underground. Again, this is a different type of foundation, similar thing. Switch to single slope, spread the reinforcing out a little bit. Conduit is underground because it's a barrier on soil. And then finally, this one is for traffic railing for mounting on a bridge deck. And so switch to single slope. Just want to point out that this one has the conduit inside the traffic railing because it's on a bridge. There's no place else for it. It's sitting on a bridge deck. And so with that, we've made it through all the indexes I wanted to explain today. And you can go ahead and see if there's any questions. We might be able to push those to the end. Okay, it sounds like you've been addressing the questions. And so with that, I'll pass this on to the next presenter.